This time we're going to look at building the fish class, what the shark's going to eat. So let's go and create a fish. And I'll just give you an idea of what it is that I want to do with the fish. So let me show you here. Basically, once the game is running, the fish will randomly appear at the left side of the screen, and they'll slowly move their way, sort of like this across, and then they remove themselves here. So basically that would mean the shark missed their chance to eat that fish as it was going by. So it's going by the sea, and then once it's out of frame, it's gone for good. But more fish will randomly appear here throughout the game. So basically the way the fish acts then, and if all I'm thinking about is the fish, is a fish does this. It basically is going to keep moving forward, and it's going to kind of move up and down sometimes. Maybe not quite as nicely as I'm doing it, but basically it's going to do something like this. And that's the behavior that I'm going to code with you here. So the way that we need to do that is we need to add a bit of randomness. And I'm going to use the setLocation method again, but this time when I do it, it's going to be random whether I go up or down. So let's just take a look here. When I move the fish, what I'd like to end up doing is I'd like to end up going some change in X and some change in Y. That way it'll have that behavior of maybe up, maybe down, and then going to the right like this. So I'm going to write a new method for it. And from this method, I'm going to be coming up with some new methods that are also going to help us out with it. So move int dx, int dy. So change in x and change in y. So all that this is going to do is it's just going to call that we're going to set the location there to where we're at plus that amount. So it'll look something like this. And then I'll say set your location to be x plus whatever change I gave you and y plus whatever change in y that was given. So in the act method then, I'll define some of the behavior for how it's going to move, but this is the method that will accomplish it. Now again, I'm going to need a method to know if I can do that or not. So let's try public boolean can move, and this is the way I'm moving, so it'd be convenient if I also based my decision on dx and dy, so relative to where the fish is right now. Okay, so I'm going to need to get my current position, and now that I know the current position, what I have to do is make sure that I'm within bounds. So to be within bounds, so what that's going to look like is x plus dx has to be greater than or equal to 0, because that's the left side of the screen. If I went anywhere less than 0, I'd be off the left side. So that's one of my conditions. I also have to make sure that I'm not off the right side of the screen. So the right side of the screen is where x plus dx is less than the width of my world. So we need a world again. We'll ask the fish to go and get it for us, and then we can query the fish about, or query the world about it. So get width. So this will be that it's within the bounds left and right. So within the bounds on the left side and within the bounds on the right side. It doesn't go past. So we still also need to check that it's above and that it's not too high up or too low down, which will be very similar here. So that means that the y plus dx, it has to be less than the world's height. And we also want to make sure that y plus whatever change in y I give it, sorry, that should have been a y, is going to be greater than or equal to 0, so that I'm not going too high up here. So that'll allow me to do my movement. There are other considerations that we might have wanted to do in this game, like for example, not allow the fish to move if it was going to bump into somebody else. But basically all that'll happen is it's going to collide with them. And according to the torpedo, that means the fish is dead. So if it collides with our shark, then we haven't done anything here, but the shark will have to deal with that. So um, anyways, now we know if we can move or not, and based on being in bounds. So that's what I'm going to do, is I'm going to say if I can move, then I'll move by that amount. Let me just show you where we're at then so far in the process. So if I can move 1 and 1, then do it. Otherwise, now it's a little extreme here that we're going to be going off the grid. I mean, basically the fish could go this way and end up getting off the grid, so that means he's going to swim away at the top or swim away at the bottom, which means it'd go through the ground. So these kind of considerations we're not going to do in our first little example game here. But again, we know it's gone off the grid here to move. So let's say we need the world so that we can remove it from the world. W.remove object, and we're removing this fish. So let's just stop here, and that's another great thing about the behavior in Greenfoot, is we can, go and test our method and see what's happening. So watch what happens when I run this. Well, it's not very interesting. It's moving in that diagonal, and it did remove itself. So things are not bad, but the reason it's doing something weird is we didn't change the way it could move. Now that might make sense for the x-coordinate, because we're saying when I started that I always wanted it moving to the right. So here, I'll make the distance always positive, so it's always moving to the right. But I don't always want it to move down like it was, meaning it's a positive y. So what I'm going to do is add some randomness to it. And I'm going to do that with the math class. So I need 3 values. I want -1, 0, and +1. So this will end up giving me numbers from 0 to 2.99, which means when I cast it to an integer, it'll be 0 to 2, and then when I subtract 1, it'll become -1 to 1. So that way the fish is sometimes going up, sometimes going down, and I guess it'll be more of a challenge for a shark to go find that fish. So that's really the only reason I wanted to add a little bit of behavior here to the fish, was that sometimes going up and down, make it a little bit more difficult for the shark. It's just sort of bouncing up and down. We could do some more tricks to it, but I just wanted to show you how randomness can help you make your game a little bit more challenging or interesting. So here, this is probably enough for what we're going to try and accomplish. I will, however, show you how we could put a little bit of extra behavior into it, just to get your brain going and thinking about what's available to you. So just like you had before, we can add extra variables here. So let me show you how you do that in Greenfoot, ones that we can keep track of in the program. They need to be declared just like you normally did, but this is the first time you've declared a variable that doesn't happen within a method. So you still have to give it the kind of access, and usually with data member variables, we usually hide them and make them private. The reason we do that is if people want to access the data, we usually require them to go through a method to do it, because otherwise they could change it and it may lose its internal consistency and make our program buggy. So generally it's going to be private when we have a variable. So I'm going to call this private int moves, and I'm going to make another one. And it's a constant, that's going to be the threshold. And I'm going to make it, let's see here, 5. We can tweak this later. But this constant, what it's going to define is how far the fish has to move before it can change the direction. That way, if it goes 5 moves, it's going to go like this, down 5, then it could go back up 5, or it could go down 5 and then down another 5. But basically, I'm saying you can't change your y value until you've moved at least that far, so it doesn't do that jerky up and down kind of thing. This being final and capitalized, you should recognize that now as the syntax for a constant. I'm going to add one other thing to this too that you've seen before but didn't realize what it was, and that's the keyword static. Now, what you're looking at, this is the template for the way that all fish behave. So really what ends up happening in the computer is each fish that's created gets its own copy of all this behavior, so that when it's acting, it's going to the method specific to that object. So you can imagine if you had 1,000 fish, you'd be copying and pasting this into memory 1,000 times, which gets fairly exhaustive. So this keyword static means that everyone in the class shares it, so that it's not repeatedly copied over. The fish, no matter which one it is, they're all looking at the same threshold of 5 moves. You could make it so that some fish go further and some fish don't, but anyways, this is just a space saving and efficiency measure. Now, what we need to do though is initialize these moves so that when the fish is first created, it hasn't moved at all, and we need to communicate that. So here's how you do initialization, and this is the new thing for you to learn about here, aside from these variables outside of your method, and that's a constructor. So a constructor is how Java knows how to build your object. And the way Java recognizes a constructor is it has the exact same name as the class. So it's just public fish, and then you can put whatever parameters you want in here. So you could define a class where you give the threshold as a parameter, but we'll stick with nothing for now. And Java recognizes it because it's the same as the class. The other thing is it doesn't have a return type, and that's not a typo, that's the way it's meant to be. So I would put all my code in here like this. I'd say moves equals 0. And this is where you initialize data about your objects. So if it's a score, or maybe like the amount of life you have, or weapons, or money, this is where initialization goes. And when you're using objects, this is the first thing that happens when somebody calls new in Java. So if you say like my string is a new string, then that is calling on the constructor for strings. So it will go right to the code and make sure everything is there so that you can build a string. Then once it's built, you have access to all of its methods, like myString dot, whatever you're doing, like a substring, etc. But the point is, the sequence is always the same. You have to build it first before you can start using it. So here inside a class, that's the way you tell Java how to build it, is in a constructor. Then, once it's been built, you can start using these methods here. You'll even notice when I right click, I'm actually using the constructor in Greenfoot when I say new fish. So the other thing though that's important to realize is doing this means a fish really does nothing except have 0 moves when I start. And that's not really correct, because a fish has a lot of things happening. It's extending this actor, and it expects all the stuff that an actor has. So if I want it to be built with everything that an actor has, I have to go and ask the actor to do it for me. So, it'd be tempting to go like new actor. Oops. But how would Java know that this is the new actor that you want, right? It's expecting you to create one by doing that. So the way you call that class is through the keyword super. You go like this and you say super. And this is asking for the super class, the actor, which is the one above. You'll notice when I go like this, it says new subclass. Subclasses are underneath, as in sub, and superclasses are the ones above. So for me to say super, it means I'm calling on the actor, and I could do just about anything here, like super.getX, and that would call on the getX method from the actor class. But in this case, what I want to do is call on the super constructor. So super, and it takes nothing. If you're not sure, you can look at the documentation, and the constructor up here is there, actor. It's just with braces like that. So that means I don't have to give it anything when I'm building a fish. So this will allow me then to initialize everything for an actor and build up all the methods and everything the way it's supposed to be. And again, now I'm just adding the specialization to it. And this is the beauty of classes and being able to reuse the same code in a new special way. So let's finish off this behavior of the way a fish is going to move now. In here, what I'm going to do is say, now that I've done that, I'm going to say moves, increment it by 1, if moves is greater than the threshold, then here's where I want to allow dy to change, possibly. So first thing I should do is reset it. So now you start fresh, you haven't moved, you hit the threshold. I'm going to now allow you to go either up or down, so start fresh with moves at 0. So dy, what I want to do is I'll declare it here, and I won't reuse it again. I'll just allow it to be updated. So the way I'm going to keep that behavior is I need to save it. So private int dy, and I don't want it here. It's going to actually belong to this fish now. So we'll initialize it. I guess I should have copy and pasted, but dy equals int math.random 3 minus 1. And it's going to remain that way because I've initialized dy, and it knows that I'm talking about the same dy here because it belongs to this fish. So that's the one it's referring to, but it's never been updated. It's going to be the same. Some might be going up, some might be going down, but it's not changed there. So in here, I'll say dy is equal to, and I'll give it some new random behavior. So basically all I'm doing in this instance now is I'm forcing it to make it all the way up to the threshold before I allow it to change the direction for y. So let's compile it and we'll see that behavior and visualize it. So now the fish is going to move further. And if it's not the kind of movement that I want, see it's moving further up and down. If I didn't like that, it's quite easy for me to change. All I have to do is change the threshold. So you could play around here and make that threshold, maybe 10, and see if it's too fast or too slow. I guess it's not speed really in this case, but too high or too low. But there it is, moving 10 at a time. So that's not bad. It's a little bit steeper than before, but maybe I'll keep it the way I initially had it at 5. Okay, so now I have my fish doing just about what I wanted it to do. So the last thing, fish behavior is done. I just have to comment another thing about the super keyword. So the inheritance, the way it works is that by calling on Java to extend the actor class, you get all of the actor methods for free. So basically you inherit them. They all come to you by declaring that a fish is an actor. It's a subclass. Now Java needs to make decisions though. Whose method do I use? In this case, because I've redefined the act method, actor has an act method too. It's right here. But because I've redefined it, Java knows that when I'm a fish, I'm going to use the act method I've provided, because what would be the point of providing one if I didn't want you to use it? So as soon as you redefine it, it no longer goes to the actor. However, anything else would be, if it didn't find it redefined, it would just go and use the actors. So that's the sequence it would do. Java says, does fish have one? Yes, it does, so use it. If it didn't, it would use the actors. So sometimes you have to be careful about which one you're calling on, because in this class, for example, if I said act, that means as soon as it's been built, it will act once. Which act will it call? It will be this method that it calls. However, maybe I don't want the fish to act. Maybe I want to actually call the actor's act method. This time, I've built the fish, and it will use the actor's method, not this one here, because I've been able to redirect it with the super keyword. Again, we have a move. This one has the same name as the actor's method, but the actor's method only takes one integer. So this is a different signature, meaning this does not override the actor class. It does not override the parent. So up here, if I was to say move 1, this directs Java right up to the actor class, but it would be the same thing as just saying move 1, because Java can't find a move method, so it's going to use actor no matter what. So when you're calling on code to be used, super helps distinguish whether you're going up to the parent or using the one that you've already done. Similarly, if you find it's clearer when you're writing your code, you could go this.act, and that's redundant in this case because there is already an act method here, but Java knows you mean, oh, I'm actually talking about the one that belongs to the fish class, not the parent class. So those are important, the super and this keywords, to understand how to use them properly. Okay, so we're getting there. We have a couple of actors in our game now. I can put one here, and I can put a torpedo. You know, maybe one good testing thing to do will be to see, can my torpedo take out the fish? Oh, so slow. Come on. There we go. So the torpedo hits a fish, it disappears. So that's kind of neat because I didn't even know about the fish class when I created this. I just said if you intersect somebody, take them out of the world. So anyways, so far we have a fish and a torpedo. We're going to start adding some other characters to this as well, starting with the shark next and adding some keyboard interaction.